Does the state you live in influence where your car is from? A researcher travels to 6 different states and takes a simple random sample of vehicles in each state and observes the following. In California, we have the states this researcher took separate simple random samples was California, Washington, Colorado, Michigan, New York, and Florida. And the types of cars they were looking at was American, German cars, Japanese cars, Korean, or other cars. Right. So we're going to now. If you expect me to expect you to do this problem by hand, you're probably right in believing that that's wrong. Because no, I don't expect you to do this by hand. That's crazy. Are you kidding me? That's ridiculous. We're gonna use our calculator, and I'll help you along if you aren't sure. I got I'm rocking out to some music in the background. So, all right. So finally expected counts of each category. We'll round that to 1 decimal place. Hopefully my numbers will fit in there. The next part we will state the hypotheses. We'll let alpha be 0.05. We'll check the requirements. We'll find the test statistic, p-value, and degrees freedom. I need my Oxford comma. There it is. And we will make the decision, and that's about all we'll do. But again, I really want to help you work through your calculator on this. So if you know what to do to start off with, hopefully you know what to do. And that is to get all of this number into a nice matrix. Question, what are the dimensions of this matrix? What? Yeah, good. Would you say 5 by 6? Because there's 5 rows. Oh, let me get a good color here. There's 5 rows. Here are my 5 rows, and here's my 6 columns. Remember, columns. There's an L in columns. There's an L to do that. This is so much fun with this program because now I can erase all those marks. Oh no. Redo. Oh, undo. There we go. Okay. So let's go ahead and put this into a matrix in our calculator. So to go through the steps here, we are going to go to second matrix, and mine is at the x to the -1 power button. So second matrix. Get to a screen that says names, and it has A, B, C, D. And we're going to scroll to the right on the top so it says edit. So we're going to edit the matrix, and let's go ahead and pick matrix 1, or sorry, matrix A. And now we have to put the step 1 is putting the dimensions of this matrix in. This is going to be important. Remember, it's rows by columns. How many rows are there? There's 5 rows. That's the German, Japanese, American, Korean, not in that order. And how many columns are there? There's 6 columns representing the 6 states. So we're going to put in 5 by 6 for the dimensions. And now I'm going to pause the video. You should pause it too. And you're going to put these numbers in, and they should come up. They should look in your matrix exactly like they look here on the screen. So I'm going to pause it right now. I'll give somebody 1 extra credit point if they can tell me who's playing, who wrote the song. But if you could figure out the background music, if you know it, it's a pretty famous piece. So if you know a little bit of Romantic era music, you might know this song. All right. So yeah, this problem looks pretty nasty, right? But you think it's hard. You think it's going to be time consuming, but I think the hardest part is just entering all this data in. And then the second longest taking part is going to be when we're going to fill out this expected matrix category. But let's actually wait to do that until we actually run through our test. So let's wait on that for just a second. Let's just begin by stating our hypotheses. And the null, if you want to pause it, give it a shot. Remember let's go back here. What's the null hypothesis? Why don't you pause it right now and give it your best chance, your best shot. Okay, so The null is that the state hypothesis state we'll say state of residence and what origin of vehicle vehicle. Oh man, what? Yeah, I think I'm gonna maybe I should have talked through this a little bit before I worded it. Remember, this is a test for homogeneity. Why is it a test for homogeneity? Because we have 6 different random samples. It's like the researcher traveled to 6 different states, took a sample every time they were at a state. So we really want to say that that the state of residence and origin of vehicle, that the distribution of the, how should we say this? It's not easy, is it? The distribution of origin of vehicles is the same for each state. Yeah, that sounds good. What did I say? Let me erase all this. What did I just say? Somebody remind me what I just said. I forgot. What did I just say? It was good. It was a winner. It was the origin of vehicle follows the same distribution in each state, at least each state in the sample, versus well, not HO. Alright, so the requirements, everything else we're going to need to run these numbers to the calculator. So let's do that. And in order to do this, I have my data plugged into the matrix, and I'm going to go to, on my calculator, to the stat button. I'm going to scroll the cursor to the right for tests. I'm going to go down to x squared, that's chi-squared test. It looks like an x, but it's the Greek letter chi. The observed is A, the expected is B, and we will just hit the button calculate, and let's just get everything while we're here. So let's write everything down for part D since we have all these. What's our test statistic? Our test statistic chi-squared is 39.29, and you look at that and you think that's pretty big. Well, yeah. What's our p-value? The p-value is 0.0061, and that's pretty small. And the degrees freedom is 20. How did we get the degrees freedom? Like if I ask you this question without, a problem like this, how do we get this degrees freedom? It was the number of rows minus 1. How many rows were there? 5. Times the columns minus 1. There are 6 columns, so it's going to be 4 times 5, which is 20. Yay! Okay, so let's go back and fill out the expected matrix, and let's kind of round this to 1 decimal place. So what we have to do to find these expected values is we'll go back to our matrix screen, so that's second x inverse. Hopefully you found it. And if we go to matrix B, we can hit matrix B, hit enter, so the matrix B comes up on the home screen, and then we'll hit enter once again and all the numbers will come out. And if yours looks anything like mine, there's a whole lot of decimal places, and I find that annoying. So we're going to use this command round, and then we'll enter matrix B, and then we'll do comma 1. Why the comma 1? That means round it to 1 decimal place. So that function round, go to your math screen, to the right to number, or num, and number 2 should be round. And then to enter this matrix B, we're just going to go back to the second matrix button, and we're going to select matrix B, and then comma 1, and hit enter. And then we should get much more palatable numbers here. So I got 79.1. And you know what? I'm just going to pause the video and enter all these numbers in right now. So hopefully your numbers agree with mine. Alright, just those numbers magically appeared, right? I think the longest part of this problem for me was just writing all these numbers into the boxes. Boy, that took me a long time. The requirements are that each expected count has to be greater than 5. So we have to scour through our expected counts here. It looks like the smallest number down here in the corner I get is 6.9, but that's certainly greater than 5. So the requirements are met. All expected counts. And you know, it's kind of like a little cop-out just to say all expected counts are greater than 5. Let's at least let the reader know where the expected counts are, or that you did something as calculated before, or as calculated above, you know, if the box is above your problem. For me, this is like in the slide before. So as calculated before are greater than 5 or exceed 5. Okay, so going to our decision here, our p-value is less than 0.05. So since our p-value is less than 0.05, we reject the null. And what did the null say? That the distributions follow the same. We reject H naught. Thus, there is convincing evidence that the distribution of vehicles, that the distribution of, not really vehicles, but origin of vehicles, distribution of origins of vehicles is not the same. Is not the same. We'll just say for these states. Alright, anything else I have to do, or did we nail it? So a couple things. On your in-class assignment on problems 3 and 4, I had asked at the end which category deviates most from expected, and you don't have to do that for the test. Some of your calculators might have a contribution function, which actually allows you to see which one of those chi-squared values is pretty much the greatest. But you're not going to have to do that for a calculator type problem. But you think you're going to have to do it for the problem that you do out by hand, kind of like number 2 in your in-class assignment? Yeah, I think so. So for number 2 with the puppies and kittens example, tell me which category deviates most from what we would expect. So you could try that one on your own. So on the in-class assignment solution, I made sure and I put to skip those, and I apologize about that. I was looking for the contributing function on the calculator, but I realized that not everybody has it on there, so you could skip those problems. Alright, if you have problems with your calculator or something, tell me before. I can answer calculator problems during the test. Come see me during office hours. If you think you know who our mystery composer is playing in the background, the piano, tell me. I'll give you like a bonus point, extra credit on your test. Alright guys, thank you. Come again.